Okay, so continuing our lesson over angular motion, we're going to use the same formulas as last time. I've put them on the same notes page, so you have to look at them. Okay, so a computer's hard drive spins at 7,200 RPM. What is the angular velocity in radians per second? Okay, so we know that 7,200 RPM is revolutions per minute. We said that one revolution has 2 pi radians. And 1 minute has 60 seconds. Okay, so we put that in the calculator. So 7,200 times 2 pi divided by 60. And we get 753.982. And that's going to be radians per second. Now it says, what is the velocity in meters per second of the hard drive at a radius of 0.0889 meters. Okay, so it's asking for the tangential velocity. So we know that Vt is equal to r omega. So your radius is 0.0889. Our omega is 753.982. So we just put that in the calculator. And you get 67.029 meters per second. So that hard drive's spinning pretty fast. Okay. Next example. It says a merry-go-round is rotating at 15 revolutions per minute and has a radius of 1.75 meters. How many revolutions did it make in 3 minutes? Okay, so I'm going to put 3 minutes over 1. And I'm going to multiply by 15 revolutions to 1 minute. Okay, so I should get 45 revolutions. Remember, from basic IPC, math problems, that sort of thing, distance is equal to velocity times time. So if I take my velocity and I multiply it by the time, I get the angular distance traveled. Okay. How long does it take for a person to make 1 complete revolution? Okay. So I'm going to set up a little proportion. I'm going to say that 15 revolutions occur in 1 minute. I want to know how many minutes does it take to have how many minutes does it take to make 1 revolution? Sorry, I lost my train of thought. Okay, so we're going to cross multiply. So we get 15x is equal to 1. So x is going to be equal to 115. So 1 over 15, if we put that in the calculator, it's going to take 0.667 minutes. If you want to convert that to seconds, multiply by 60. So it'd take 4 seconds. Okay. C. It says, what is the velocity in meters per second of a person standing on its edge of the merry-go-round? So we're looking for Vt. So Vt is equal to r omega. Now our omega needs to be in radians per second. So we're going to say 15 revolutions to 1 minute. 1 revolution has 2 pi radians, and 1 minute has 60 seconds. Okay, so we're going to do 15 times 2 pi divided by 60, and we get 1.571 radians per second. Okay, So we're just going to plug into our formula now. Our radius is going to be 1.75. We're going to multiply that by 1.571. And we get 2.748 meters per second. 79 if you want to round up. Okay, last one. It says, how long will it take for a helicopter blade to turn through 200 radians if its angular velocity is 60 radians per second? Okay, so I'm going to start with 200 radians over 1. I'm going to multiply by this rate. So 60 rads has to go on the bottom because the units have to cross cancel, and I have the 1 second on top. So 200 divided by 60 is 3.33 seconds. Now, so back in IPC, or basic math, we learned this little triangle. So it says, how long will it take for the helicopter to turn through? Okay, so we're looking for time. The angular distance is 200, and the angular velocity is 60. So distance divided by time, which is what we did. Distance divided by velocity gives you time. So we did 200 divided by 60, and you get the 3.333. Hopefully this video was helpful, and if you have any questions, feel free to reach out. Thanks. Bye.